when I use all those production rules in some order and I am able to generate that language. That is the one solution. For the same problem, I am using the same production rule but in some other order. See here, you are having some rules, rule 1, rule 2, rule 3, rule 4. There is a one problem. Whenever you want to solve this problem, at that time you are using all these production rules. Okay, like this. First I applied rule 1, then I applied rule 2, then I applied rule 3, then I applied rule 4. So that I just succeed. I just got that language. Finally I able to generate that language. This is one solution. For the same problem, I am using same production rules but not in this order. I am using some other order. See, I used first second rule, then I used third rule, then I am using first rule, then I am using fourth rule. In this case also I able to produced, I able to generated that particular language. See here what I am understanding. For a single problem, by using same kind of production rule in some order, we are generating that language. So here you are understanding that there is one problem is having more than one solution. See here I am telling more than one leftmost derivation or more than one rightmost derivation or more than one parse tree. So there is a one problem which is having more than one solution, is called ambiguity. First of all, what is leftmost derivation tree? First of all, what is derivation tree? Derivation tree is also called parse tree. Parse tree is also called syntax tree. So derivation tree, parse tree, syntax tree, all are same. What is the purpose? Why we people are using parse trees? Why we people are using derivation trees? The reason is, for a problem we are using grammar. Whenever we want to represent them with the help of the trees, with the help of the graphical, at that time we are using these derivation trees. So when it comes to derivation trees, we are having two type of trees are available. One is leftmost derivation tree and second one is the rightmost derivation tree. Leftmost mean there we are following leftmost, there we are following some rules. Those rules are different when we are using the rightmost derivation trees. See here, you please understand that leftmost derivation trees we need to follow some rules. For generating rightmost derivation tree we are following some other rules. Both rules are different. Is it clear? Next, let me explain these derivation trees with the help of by taking one example. My example is, check whether the grammar G with production rule is ambiguity or not. My grammar is G, here my X sometimes it goes to X plus X, sometimes it goes to X plus S, sometimes my X goes to X into X, sometimes my X goes to X, and sometimes my X goes to A. So totally this is my grammar. In my grammar left hand side X will be there. My X sometimes goes to X plus X, sometimes it goes to X into X, sometimes it goes to X, sometimes it goes to A. So here by seeing this diagram, I can able to understand that my X goes to X plus X sometimes, my X goes to sometimes X into X, sometimes my X goes to X, sometimes my X goes to A. This is my grammar. Totally 4 production rules are there. Now by using this grammar, what I am doing, I am going to check whether this particular string, what is my string? a plus a star a. Can I able to generate this particular string by using this grammar? Is it possible or not? Suppose if it is possible, you can say that this is context free language. Suppose if you are able to generate this particular string by using this particular grammar in two ways, which is nothing but ambiguity is there. That means there is a one problem. What is my problem? There is a one grammar. See, this is my grammar. By using this grammar, if I able to generate this particular string, then that is called the grammar. That is called the context free grammar. Suppose if I able to give two solution for this particular solution for this problem, then that is called the ambiguity. See, first of all, for this here, first solution is I am checking derivation 1 is there. So first of all, my x goes to x plus x. My x goes to x plus x. In the place of x plus x, I am applying fourth rule, which is nothing but x goes to a. X goes to a. I just applied a here. Now it gives a plus x. A plus x. Now I am going to apply second rule. What is my second rule? X goes to x into x. See here a is there. A plus, now I am applying second rule, which is nothing but x goes to x into x. X goes to x into x. Now it goes to, now again I am applying fourth rule, which is nothing but a plus, in the place of this x I am applying a plus a star x. Now again I am applying a, in the place of x I am applying a. See here, if you observe clearly, first x tends to x plus s. That means I applied rule 1. First I applied rule 1. Then I applied see, then I applied fourth rule. What is my fourth rule? X tends to a. Then I applied x tends to 2. Then I applied 4. So this is the order. I taken all production rule, and I can able to generate my required string from this grammar. Now I can say this is my context free grammar. Now I am searching for, is there any alternative method to get that particular thing. See here, this is my x. First x tends to x plus x. This is my leftmost. So here I am applying x tends to x into x. Then I am applying x goes to a, which is nothing but a plus a into a. This is my first methodology. So, and my second methodology, here instead of applying x tends to x plus x, I just used x into x. In my previous derivation, in derivation 1, what is my first step? There my first step is 1. But here what is my first step? My first step is 2. See here x tends to x into x. So in the place of x, I am applying x plus s. That means I am applying rule 1. Now it becomes x plus x into x. Now I am applying fourth rule. In this place of x, I am applying a. Now it becomes a plus x into x. Now again I am applying fourth rule, a plus a into x. Again I am applying fourth rule in the place of x, a plus a into a. Now I understood that for the single problem, I have two ways.